Every component of the modern fast food environment, from the weight of the fry basket plunging into the oil to the specific hum of the ventilation, functions as a biological extraction mechanism. This architecture is engineered to interface directly with human neurology. While we approach the counter under the assumption of autonomy, the environment is designed to guide individual choice through a series of calculated physical and sensory prompts. In this space, the final order is frequently a reflection of the environment's layout, rather than the customer's original intent. The structural variables of the building, lighting, spatial flow, and transaction speed, are mathematically tuned to favor rapid decision-making over deliberate, slow cognitive processing. By accelerating the pace of the interaction, the architecture routes decision-making away from analytical thought and toward the automatic, craving-driven responses of the limbic system. This spatial design specifically targets the prefrontal cortex, seeking to circumvent the brain's capacity for rational oversight. To see how this works, we have to look at the specific spatial and chemical triggers that precede the moment of consumption. The fast food environment operates by narrowing the window where a customer can exercise the choice to refuse. The process begins with sensory priming, an influence that takes hold before a customer even enters the building. Fry oil compounds are formulated for high chemical volatility, ensuring that scent particles achieve wide spatial dispersal across the surrounding area. These airborne compounds interact with the olfactory system to trigger an anticipatory release of dopamine. This neurochemical response occurs before the frontal lobe can evaluate actual physiological hunger levels, creating a state of readiness for consumption regardless of physical need. Inside the space, the triggers transition to the visual spectrum. Specific wavelengths of warm reds and yellows are utilized because of their direct impact on the brain's urgency and appetite centers. These colors bypass aesthetic preference, instead stimulating the neurological perception of hunger and the desire for a rapid transaction. At the same time, auditory frequencies and brand jingles are tuned to trigger comfort recall, further lowering cognitive resistance. The hunger felt at the counter is a manufactured biological state, generated by the specific sensory conditions of the building. The menu board employs a mechanism known as anchoring to dictate the perceived value of its items. This relies on cognitive arbitrage, a process where the brain stops calculating absolute cost and begins making rapid, relative comparisons between the numbers provided. We can see this anchor on this scale. Placing a premium item prominently resets expectations for everything else. This disrupts the prefrontal cortex's cost-benefit analysis, forcing the brain to accept a fast, relative comparison as a substitute for objective judgment. This forced neurological trade ensures that the customer perceives a deal where the designer has already secured the desired margin. The customer's sense of financial benefit is a mapped response to the specific numerical variables displayed on the board. Perceived savings are a function of how the data is framed, guiding the customer toward a pre-calculated choice. The drive-thru operates as a friction removal system designed to facilitate immediate action. The engineering goal is to collapse the time between the initial impulse and the moment of consumption. By limiting the text and visual options on the outdoor menu, the system prevents the customer from engaging in a slow, analytical review of their choices. Enforced verbal pacing from the speaker box script then requires the customer to follow an artificial, accelerated tempo. Every second removed from the order time further reduces the temporal window required for the brain to exercise rational oversight or reconsider a craving. This removal of friction pushes decision-making into impulsive, automatic neurological pathways. Friction is the primary obstacle to immediate consumption. The system is built to eliminate it. Extreme ordering efficiency effectively removes the customer's final opportunity for deliberation. Hyperpalatability describes a formulated ratio of fat, sugar, and sodium designed to override the body's internal satiety signals. Combinations of high fat and sugar lack an evolved ceiling in nature. As this exponential line shows, human dopamine pleasure signals rise limitlessly. Meanwhile, the declining line shows blunted leptin sensitivity. This delays satiety signals, allowing consumption long after physical needs are met. This chemical bypass is supported by portion distortion. Repeated exposure to expanded sizes resets the brain's visual baseline for a normal serving. The visual recalibration and the chemical blunting of leptin, work together to obscure the actual volume of food being consumed. The system achieves its goal by making the physical feeling of being full increasingly difficult for the body to register. Consumption becomes the absorption of a formula that recalibrates the body's own definition of enough. Limited time items introduce an unpredictable reinforcement schedule into the menu. These items tap into the same intermittent reinforcement circuitry that drives compulsive behaviors in other contexts, like gambling. The uncertainty regarding when an item might disappear amplifies the brain's dopamine response beyond what is triggered by items that are always available. The focus of the craving is not the specific ingredients of the product itself. Instead, the impulse is driven by the neurological response to the possibility of losing access to the item. Artificial scarcity is the psychological mechanism used to ensure the customer returns to the apparatus. The mechanisms of the fast food apparatus, from priming to hyperpalatability, depend on the absence of friction to remain effective. The 72-hour cognitive insulation role provides a structural defense against this environmental hijacking. By mandating a 3-day delay between a triggered craving and the act of eating, the automated feedback loop is interrupted. This interval removes the immediate reinforcement the nucleus accumbens requires to sustain a compulsive impulse. The delay provides the time necessary for the prefrontal cortex to re-engage and evaluate the decision with deliberate judgment. This protocol restores the variable of time, the one factor the fast food system is designed to eliminate. When judgment is delayed, the effectiveness of anchored pricing and sensory priming is significantly diminished. The apparatus is built for speed, not for the endurance of the human mind. By reintroducing friction, the system loses its control.